Sample problem number 19. So this is one of those more complex algebraic expression type questions. And as I'd mentioned in earlier classes, that one of the things that I'm trying to teach you how to do is to solve problems entirely in the algebraic space. And this is a perfect example of the kind of questions you would receive in not only grade 12, but in first and second year university. So we have a 975 kilogram race car, and it's experiencing a frictional drag of mu is equal to 0.95 as it's racing down the road. End sentence. In addition, let's fix the grammar fail here. It is experiencing a downward force, one word, due to its aerodynamic design of 1,300 newtons. Yikes. The race car is accelerating at 5 meters per second squared. Part A, you're asked to derive an algebraic expression for the drive force of the car. Now, I'm calling it FE because we have the downward force and the drive force. Since both kind of start with the letter D, I'm going to use FE for force of engine. Or if you like, you could use FR for force of race car, or whatever floats your boat. FE seems to make sense to me. Now, you need to derive this algebraic expression for this drive force in terms of the following variables. So the final expression, and this is what I have to articulate to you, must involve the following variables. Obviously, FE has to be in there. And the expression must include the letters M for mass, mu for the coefficient of drag, G, which is the magnitude of the acceleration due to gravity, FD, which is that downward force, and of course, A, which is the acceleration of the vehicle. Then you are to actually solve for the value for FE. Part A is worth the most in this case because that is really what the question is assessing, is your ability to derive this thing entirely algebraically. Let's start off by focusing on the given section. All right, so we know the mass, and that's 975 kilograms. We have the mu, we have the downward force, and we have the acceleration given. Now, we are looking for the force of the engine. Before you do any algebra, we need a proper free body diagram. So when we draw the free body diagram, here's what's going on with it. Let's start off with the x-axis. So in the x-axis, we have the force of the engine. And let's make that a little bit more clear. The force of the engine. This is what's driving it in the forward direction. So in terms of the acceleration of the vehicle is in the forward direction, which means that this FE should be a larger value than the force of friction. So this is what's happening in the x-axis. Of course, in the y-axis, we have the normal force, the force of gravity, and this extra downward force from the aerodynamic shape. And that comes from the spoilers and the wind scoops in the race car design. In normal circumstances, the sum of all the forces down must be counterbalanced by all the forces acting up. In this case, the upward force is the normal force, and the downward forces are the weight of the vehicle itself and that downward force as a result of those airfoils on the vehicle. And remember, in a normal circumstance, the acceleration should only happen along the ground. The car should not be floating or sinking. Since we are looking for FE, we're going to start with F net X. So focusing on F net X. So F net X is equal to the force of the engine, which is what we're looking for, plus the force of friction. Okay, now remember, we are trying to get this in terms of the following variables: FE, M, G, mu, and A. What that means is that anything that are not these variables, we must get rid of. And I forgot one, and the downward force. That's important too. So we need to have these variables only in our final expression. What that means is that I have to make a replacement for F net, and I'm going to have to make a replacement for the force of friction to get us where we got to go. Okay, so next, we know that the net force is equal to mass times acceleration. All right, great. So look what we've done. We've got M and A introduced. Good start. Of course, FE is in the positive direction. So we've got that. And then the formula for the force of friction is equal to mu Fn. Perfect. So now we make the replacement for the force of friction with mu Fn. And that means we have now introduced our symbol mu. Let's make that a better check mark. And then we have mu over here. Okay, so now what we have now done is we've now introduced a new variable, the normal force. But that isn't one of the variables that we want our final equation to be. So we're going to have to make a replacement for the normal force. We still are missing these two as well. So not only do we need to get rid of the normal force, but we have to be able to introduce little g and FD. Well, those two forces, those two parameters and that normal force, that is all associated with the y component. So the next thing we're going to do is we're going to move over to fnet y. So you would pause here for a moment, and then we move over to fnet y. Well, actually, that's not precisely what I didn't do, sorry. So actually, I should clarify what I did first. So we do know that we have to figure out our fn, but what I did actually is I isolated for fe. So when we look at this, we have, of course, fe is our term of concern. So we need to move this term to the other side, which makes it addition. Now, by doing it this way, I can then rearrange it so that I'm a little closer to the final equation that I want, which is fe is equal to ma plus mu. And then now we're going to deal with this fn business. So now let's go over to fnet y. So fnet y is equal to our fn plus our fg plus our fd. Now, the key thing is to remember is that fnet y is 0 because it's not floating or sinking. So fnet y is equal to 0. Our normal force is in the positive direction because it is going up. Our force of gravity is negative, and the formula for the force of gravity is mg. Fg equals mg, of course. And then our downward force is negative. As you can see, we have now introduced the variable g and fd. The next step is to isolate for our term of concern. So that means I have to bring these two terms to the other side. And when I do that, they become positive. So we get mg plus fd, and this is all magnitudes at this point, is equal to fn, or fn is equal to mg plus fd. Awesome. And we call that our equation 2. Next step is we substitute our equation 2, this, into here. Now, the key thing is to remember, and I'm going to highlight these, don't forget your brackets. And that is key. So when you make this replacement, don't forget the brackets here. Now that we've done that, we're exactly where we need to be. So let's take a look. We now have, we can replace these question marks with check marks. So we have all of the symbols in our expression. Fe is equal to ma plus mu, mg plus fd. Everything's accounted for. And this is our algebraic expression. Part 2, or part B, I should say, now we take that algebraic expression and then we calculate. So we simply now just substitute for everything in. So we have a mass of 975, an acceleration of positive 5. Our mu is 0.95, our mass again of 975, 9.8 for the magnitude of g, and that FD is equal to 1300 newtons. Now, some of you are saying, wait a minute, shouldn't that be negative? No. This is definitely positive. It should not be negative. But I thought it was down. Yeah, it is down. And that's why we made it negative here. We already made it negative. See, this is a tricky thing, except I'm looking at the right thing. Let me make that letter D a little bit more pronounced. That looks like a P now. There we go. There, that's a little bit better. We've already made it negative here. That is the direction. But when we brought it to the other side, humans of profound awesomeness, when we bring it to the other side, that negative turns into a positive. So we've already made it negative. You can't make it negative again. Otherwise, bad things happen algebraically. Okay, after we substitute everything in, we get all this calculator vomit here. Therefore, Fe is equal to, now let's see how many sig figs we should be doing this with. Well, it looks like 4, 5, and 4. Okay, so 4 sig figs. So we round off our answer, 1, 2, 3, 4, right there. Okay, so when we do that, that will be 15,190 newtons. And that will be in the forward direction.